He's also in the department, is not here today, so I'm going to introduce our next speaker, which is Nguyen. I've had on for a couple of classes, and he is interested in forensics, but also the application of ecology into forensics, which is a really nice interdisciplinary approach to ensuring that these forensic approaches of trying to understand time of death and also location of death can be really important in order to make sure that the work is more accurate and also faster. So An is taking entomology courses with me to understand the insect side of forensics, and so that's a very important aspect. But something that's under study is certainly soil properties that go with trying to understand these forensic investigations. And so Dr. Wofford did a great effort of trying to overlap these two seemingly disparate disciplines into something that's combined. So An is going to talk about some of this neat work, and I'll let him speak.
Hello, everyone. So initially this proposal that I started was to understand how to model cadaver decomposition on but previous research on this showed that soil testing, even within the same field, was vastly different from each other, and it's hard to get like a nice homogeneous sample of soil. So under the direction of Dr. Wofford and Dr. Kelly Gregg, it was concluded that expert knowledge is necessary to model specifically a CDI model. So instead we moved more towards figuring out how we can make a post-mortem interval. This research is to complement information collected by laymen from soil at crime scenes. So we looked into the possibility of generalizing soils. There's a lot of different kinds of soil types specifically, but NCRS, National Resources Conservation Services Web Soil Survey Tool is an excellent resource. I feel like it's very applicable for laymen to use once you learn how to use it. Sorry, I switched already. Good. So, with the initial research looked at, their model assumptions went on homogeneous soil, homogeneous pellet pressure, and a constant fluid mass. When a body is deposited into onto the ground, like in a clandestine grave, it's not going to constantly just emit that nutrient deposit at a constant rate. It's going to depend on environmental parameters such as the weather, the temperature, for that skin to be intact or release that nutrient fluid. Current soil analysis techniques that are used are the Labrador, non-cell soil test, density gradient column, and ground penetrating radar. The Labrador stands for Lightweight Analyzer for Buried Remains and Decomposition Odor Recognition. Is a mass spectrometer field equipment. It's most notable for being used in the Casey Anthony test, the Casey Anthony case, where it's kind of used to sniff for what Voss, the grant writer for and Greater Labrador, used to say you could specify decomposition particles specific to human decomposition. But this specific research hasn't actually been used, it didn't meet the Dalbert standards, which, it's where an expert witness may test to the reliability of principles and methods used in analyzing or gathering evidence. So essentially, Labrador didn't meet up to that same standard, as why in that case, the prosecution failed. So this right here is ground penetrating radar. And these 6 graves, these 6 graves right here, these are the control and 1 deep burial for pig carcasses. After 21 months, you can't even detect the graves anymore, so it's limited in use, but can be useful in combination with other methods. Forensic research is oversaturated with insect research, mainly concerning diptera metamorphosis involved in early stages of decomposition. However, advanced stages of decay, insects will migrate into the soil, which highlights the importance of accounting for subsoil and topsoil interactions. But even minor weather events such as rain can wash people casings into the ground, and that can compromise your estimate of time of death. In this case, the Enrique Camarena case, soil was found on cadavers that were inconsistent with the crime scene. So we're looking at like Munsell soil tests were used to dry the soil and analyze it, and they found they had types of brown volcanic ash and fragments of rhyolite, which told them that the cadavers had been moved from somewhere near charred grass. So if we could revisit this case and apply it with our proposed post-mortem interval analysis, what we want to look at is analyzing the initial gravesite and measuring the effect of the cadaver deposit and the exhumation effect on the vegetation. Now, cadaver decomposition island is formed when a pulse of water, carbon, and other nutrients are deposited in the soil. Vegetation is observed dying through smothering and leachate. The lateral extent of the CDI changes over time, as you can see. Even beyond Payne's proposed 6 stages of decomposition, which is fresh, bloated, active decay, advanced decay, dry, and remains. So this right here is a sigmoidal curve of decomposition where the presence of skin retains moisture and determines the rate at which blowphyllari consume cadaveric material. The next part of this is understanding how to actually document this kind of evidence. So as decomposition leaches into the chemical compounds into the soil, this affects the surrounding vegetation. Here, after a few months or weeks, you can see like the burn around the pig corpse, and even further you see the nutrients, the vegetation around has recovered somewhat as around the cadaver is still damaged. This mainly applies for smaller carcasses where the cadaver cannot be carried away by scavengers. Pardon me. Okay. The reason why I started this research was because I was inspired by Alabama Water Watch's monitoring methods of measuring standard biological, chemical, and organismal properties of bodies of water. And I wanted to know if there was a way to kind of model a similar kind of standard research for soil sampling. Because Water Watch is very engaging, and I feel like it would be just as engaging to take soil samples in your community. So for future research, I'd be really interested in applying a model where the user inserts different generic soil types and variables to estimate kind of a window for a post-mortem interval. This here is our lovely city of Jacksonville, and overlaid right now is the NRCS Web Soil Survey Tool data on hydrologic soil groups. As you can see, it looks a little bit overwhelming. Each of those little points is a species of soil, but within the Web Soil tool, it limits the hydrologic groups to A, B, C, and D, which run respectively from high to low infiltration. The only problem with hydrologic groups is they don't consider vegetation impacts or surface runoff classification. The surface runoff classification does consider these, including slope and minimal irregularity. So it wouldn't necessarily apply if we're looking at crime scenes specifically, but it will help us create a standard to compare these crime scenes to. So using these generic soil classes, further research may be used to model this information to predict the movement of CDIs as they're deposited into the ground and distributed to the surrounding vegetation. And that's all I have today.